Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about TCP/IP reference model. Today, we are going to discuss what is TCP/IP. TCP stands for Transmission Control Protocol, IP stands for Internet Protocol. In computer networks, there are two reference models. Two reference models are OSI reference model, that is Open System Interconnection, and TCP/IP reference model. In previous section, we already discussed OSI reference model. Today, we are going to discussing about TCP/IP reference model. First, let us see the overview of today's session. First, we are going to discussing about what is TCP/IP reference model, that is Transmission Control Protocol and Internet Protocol. And next, we are going to discussing about TCP/IP architecture. What is the architecture? How many layers are there in TCP/IP? All we are going to discussing TCP architecture. And next, we are going to discussing about the layers in TCP/IP architecture. There are 4 layers in TCP/IP architecture. Those are application layer, transport layer, network layer, that is also called as internet layer, and next network access layer. These are all 4 layers we are going to discuss in TCP/IP reference model. And next, we are going to discussing about the TCP/IP PDU, that is Protocol Data Unit. What is the TCP/IP exact protocol data units? How the data is going to be passed from application layer to network access layer? Those all we are seeing in Protocol Data Unit. And next, finally, we are going to discussing about differences between TCP/IP and OSI reference model. These are all topics we are going to discussing in today's session. First, we have to see what is TCP/IP reference model. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol model. This is the network model mainly used in the current internet architecture. Means wherever we are going to use a network architecture, there we are going to use TCP/IP reference model. And it was developed by DoD, that is Department of Defense Project Research Agency in 1960s. It is developed in the year of 1960s. That is developed by Department of Defense Project Research Agency. And next, it is main aim to transfer the data from one device to another device. That is the main aim of TCP/IP reference model. And also it ensures the receiver will receive the same information which is sent by the sender. Means whatever sender is sending the information, at the same time receiver also receive the same information whatever sender is sending. Means suppose if the sender is sending, if it is the sender, the sender is sending the information of 1 KB. So, exactly the receiver also receives the information 1 KB only. That is TCP/IP reference model. At the same time, it is also providing the reliable and accurate communication in between the sender and sender. Whatever communication is there in between sender and receiver, that is reliable. At the same time, it is accurate. That is the TCP/IP reference model. And mainly it is used to remote system connection. Means if you want to connect to the remote machine, we are going to use the TCP/IP reference model. These TCP/IP is having the 4 layers. These 4 layers are the application layer, transport layer, network layer, that is internet layer, and next one the network access layer. These are the 4 layers in TCP/IP reference model. First, let us see what is the architecture of the TCP/IP reference model. So, this is the architecture of the TCP/IP reference model. See, already we discussed in previous session, OSI is having the 7 layers and TCP/IP is having the 4 layers. So, the relation in between the OSI and TCP in application in OSI layer, it is having in this model, it is having the 7 layers, right? These are the 7 layers we are using in OSI reference model. These 7 layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. These are the 7 layers in OSI reference model. And coming to TCP/IP, it is having the application layer, transport layer, network layer, and network access layer. The relation is combination of these 3, like application layer, presentation layer, session layers. We can call it as a application layer in TCP/IP. While coming to transport layer in OSI, it is also called in TCP as called as transport layer only. And coming to network layer, this network layer as usual used in the TCP/IP, that is network layer. And next one, the combination of the data link layer and physical layer, that is called as the network access layer in the TCP/IP reference model. So, we already discussed the functionalities of each and every layer in the OSI, right? What is the main application of the OSI reference model is? What is the main application is? for selecting the application, through which application you want to transfer the data. That is the main aim of the application layer. That is the main functionality. At the same time, it is providing the interface in between the sender and receiver. Means it is providing the main interface in between the user and application, through which application you want to send the data. That is the application layer functionality. And coming to presentation layer functionality here, through which format you are sending the data. Means that may be your PDF file, PPT, document, anything, which format you want to send the data. That is the main function of the presentation layer. It is talking about the syntax. Semantics, and also it is talking about the semantics, and next it is also talking about the next one is the presentation. Means what exactly you are sending the data, means encryption and decryption. Suppose if the confidential information is sending, that is also comes under encryption, decryption also comes under presentation layer only. Those are all functionalities comes under presentation layer. And coming to the session layer, what is the main aim of the session layer? For transferring this all data, you selected some application, that may be your WhatsApp application you selected, and then selecting the format you are sending the format in the form of PPT format. And next session, first if you want to send the data to that particular receiver, first you have to connect through the internet. Without connecting the internet, you can't send the data. So that first you have to select the connecting to the internet. That then whenever you are connecting to the internet, then your session is going to be started. That is session layer work. The same time, whenever you are logged out from that particular application, that is session layer. Your session is going to be ended. That is the session. Your session is started and ended here only. Here it is talking about the dialog control, and at the same time synchronization. These two comes under dialog control and synchronization. These two comes under session layer only. And next one is the network layer. What is network layer work? Next one is the transport layer. What is the transport layer work? Is nothing but whatever data is going to be transferred from the session layer. Means you have selected the WhatsApp application, you selected PPT, the session is going to be started, it is connected to the internet. Next, the data is going to be transferred. Means it is going to be transferred from your end to receiver end. That is the transport layer. And next one is the network layer. What is network layer? Here is nothing but it is transferred through the different networks through the logical address. It is nothing but logical address. It is talking about the logical address through IP address, means internet protocol address. That is the logical address. Means exactly which network you have to reach. That is nothing but network layer. And next one is the data link layer. What is the functionality of the data link layer? Is nothing but it is providing the physical address, means through exactly which device I want to reach the data, using MAC address, means media access controller address, to the MAC address, through which particular MAC address you want to reach the data, means through the particular MAC address, that is which device you want to reach the data. That is the data link layer. And coming to physical layer, what is the physical layer? Means after coming to your device, through which exactly how the data is going to be transferred from device A to device B. That is the physical layer in the form of wires, wire medium or wireless medium. How the data is going to be transferred in the form of wired and wireless medium. It is going to be converted in the form of bits only. That is the physical layer work. These are all functionalities, how it is working in OSI layer. Same it is also working in TCP also. That is through these four applications, the data is going to be transferred from the sender to the receiver. While coming to the application layer in TCP IP, see in this application layer, so the combination of application session presentation is nothing but application layer only, right? So it is also talking about the selecting the application, at the same time next presentation layer work is nothing but in which format you are sending the data, that may be encryption, decryption, and at the same time syntax, semantics, all comes under an application layer only. And coming to the session also involved in this, right? These three, right? This session is nothing but creating the session for dialog control and synchronization. All comes under application layer in TCP IP reference model. And coming to the transport layer, for transferring the data in between end to end, from receiver end and sender end. And next one is the network layer, transferring the message to the packets using IP address. IP address, internet protocol address, that is the logical address for transferring the packets. That is the network layer work. And next one is the network access layer. It is the combination of data link layer and the physical layer. Data link layer work is nothing but what? Creating the frames. That is nothing but framing. And next one is, it is also having the MAC address, means exactly which device I want to reach the data. That is data link layer work. At the same time, physical layer means whatever data is going to be converted, that is in the form of bits, that is in physical layer, that is converted to the bits, that is also transferred into the physical media. These are the functions of the network access layer. This is about the OSI and TCP architecture. This is the main relation in between the OS and TCP IP architecture. And let us see the each and every layer functionality. What are the protocols we are using in application layer, transport layer, network access layer. All we are going to see now. First is the application layer. Application layer main work is nothing but the interaction in between the user and application. So it is providing the interface in between the user and application is nothing but the application layer. The main aim is nothing but selecting the particular application. Selecting the application through which application you want to sending the data. That is the application layer work. And next one is it accesses the global information about it, providing the objects and services. At the same time, here the data is going to be formatted, that is presentation layer, converted, encryption, decryption, all comes under application layer only. That is application layer. Coming to the example, social apps like WhatsApp, Instagram, Facebook, all different applications, all comes under application layer only. Banking apps also, Gmail applications, and file transfer applications which are you are going to use, gaming applications and browsers, these are all comes under application layer only. These are the different examples for application layer. And coming to the protocols in the application layer, what are the main protocols you are using in application layer? Those are HTTP, that is Hypertext Transfer Protocol, SNTP, that is Simple Mail Transfer Protocol, FTP, that is File Transfer Protocol, and Telnet, that is Telecommunication Networking, and DNS, Domain Name System. These are the protocols we are using in application layer. What is the main aim of each and every protocol? We will see now. First, what is HTTP? HTTP is mainly for what purpose? It is going to be accessing the information available on the internet. For that purpose, we are going to use the Hypertext Transfer Protocol. And next one is Simple Mail Transfer Protocol. Here only it is there. SMTP is nothing but Simple Mail Transfer Protocol. So, here only it is there for transferring the mail in between the sender and receiver. We are going to use the Simple Mail Transfer Protocol. And coming to FTP, what is FTP? File Transferring Protocol. File, whatever files are there for transmitting the files, we are going to use the File Transfer Protocol. And next one is the Telecommunication Network. Telecommunication Network mainly for establishing the connection in between the local computer as well as the remote computer. That is the functionality of Telnet. And next one is DNS, Domain Name System. What is the main aim of DNS is Domain Name System is for translating the human readable domain name into machine readable IP address. That is the main aim of DNS. That is the important protocol in application layer. See, DNS is nothing but, suppose take this example www. We all know, we don't know an exact IP address, that we know only the exact human readable domain address only. That is, suppose if take the example is www.google.com is everyone, this is not, but the exact IP address of this is this one. But we don't know this particular address. For connecting this address to human readable address to machine readable address, we are going to use the domain name system, that is DNS. These are the different protocols we are using in application layer. And next layer is transport layer. This is the second layer in TCP IP reference model. What is transport layer here? It is the main responsible for what? End-to-end communication. At the same time, error-free delivery of the data. Transport layer is nothing but mean from sender to receiver. From sender to receiver, how the data is going to be sending and receiving the data. That is end-to-end communication. At the same time, it provides the both connection-oriented and connectionless services. It providing the connectionless, at the same time connectionless and also connection oriented. Both it is going to be provided. Connection oriented. These two services provided by the transport layer. And it is also providing the flow control and error control. Flow control is nothing but whatever data you are going to send. This how much data is going to be sent per second. Per second, how much data you are going to send to the receiver. At the same time, at what speed you are sending the data. Exactly per second, how much data you are sending. At what speed you are sending the data. These two comes under flow control. And next one is error control. Whenever you are sending the data from sender to the receiver, there may be chance of errors also, right? To ensure the data units delivered error-free in a sequence. For that purpose, we are going to using error control. Here we are going to use error correction and error detection. These two techniques for correction and detecting the errors for error control. And next one is what are the different protocols we are using in transport layer. So, this transport layer is mainly providing the two protocols. Those are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. These protocols comes under transport layer. What is TCP here? It is establishing the connection between the source and destination. TCP is a connection-oriented protocol. It is a connection-oriented protocol. And coming to UDP, it is a connectionless protocol. Connectionless protocol. We already told it is providing the connection-oriented and connectionless. So, TCP for connection-oriented, UDP for connectionless. It establishing the connection-oriented. The same time, the transport layer is TCP collecting all the segments, right? It is in the form of segments only, right? Transport layer, whatever data is going to be saved, that is in the form of segments only. Means, but this TCP is collecting all the segments and that is going to be reorder them based on the sequence number. That is the main aim of the TCP. At the same time, it is a connection-oriented protocol and also it is taking the feedback that the data is transmitted at the destination. Means, suppose if this is the sender, this is the receiver, this is the sender and this is the receiver. Suppose if the sender is sending the data from sender to the receiver, first it will give the receiver give the acknowledgement to the sender. Yes, I received the data. Like that, it is giving some acknowledgement to the sender. That is nothing but connection-oriented protocol. Giving the feedback means acknowledgement is giving. It is also reliable protocol. Means it detects the error and retransmit the damaged segments. Suppose if any errors are going to be there in between transferring the data, it will detect the error and it will correct the error. That is comes under transmission control protocol. And coming to user datagram protocol, mainly it is a connectionless service and it is also transferring the data from one end to another end. It is a unreliable protocol. So, it is a reliable protocol TCP and coming to UDP, it is an unreliable protocol because it discovers the error, means it detects the error but it did not recover the error, means it does not correct the errors. That is the main difference between TCP and UDP. Here it is detection and correction both will done. Coming to here, it detection the error but it does not correct the error. That is the UDP. And UDP is faster than TCP because it is connectionless service. It is a connection oriented service, means because every time it is asking the acknowledgement. Here it is does not need acknowledgement, any acknowledgement. It is just sending the data. Whatever data you want, you are sending the data. But whether the receiver is received the data or not, it won't bother about that. That is the UDP. So, it is faster than the TCP. TCP can perform the verification at the each step. That's why UDP is the faster than TCP. And these are the protocols we are using in transport layer. And coming to next layer is network layer. What is the network layer? Whatever data is going to be transferred in the form of packets in network layer, that we already know. Yes, it is also called as internet layer and it is also called as IP layer. This is the network layer. And whatever data is going to be there, that is in the form of packets, from any network it is going to be send the packets. And also it decides the shortest path for the routing. So, suppose for this sender sending the data to this particular receiver. This is the sender, this is the receiver. To sending the data, it is having multiple routes for sending this particular data. Means it will select the best route. Which one is the best route among these all paths? That is the deciding the shortest path for the routing. Through which route I have to select the data, for sending the data. That is the main aim of the network layer. And the protocols in the network internet layer are IP, that is Internet Protocol Layer, that is the protocol, and next one is the ICMP, Internet Control Message Protocol, that is also one of the protocol, and ARP, Address Resolution Protocol. These are the protocols we are going to discuss in Internet Layer. First, IP it is also having the version 4 and version 6 also. These two are the Internet protocols. So, it is delivered, the main aim of this IP protocol is, it is delivered the packet from the source to destination host. Whatever packet is going to be there, that is going to be delivered from the source to destination host by following the IP address. Mainly the main work of this network layer is selecting the data, means through which address you are sending the data, using the IP address only. Using the IP address we are going to send that particular network. And next one is IPMP. What is ICMP? Internet Control Message Protocol. It is providing the information to the particular host in case of network problems. If any network problems are there, like error reporting protocol, it is a error reporting protocol. If any problem is going to be there, that is going to be provided by the Internet Control Message Protocol. And coming to ARP, what is ARP? Address Resolution Protocol. What is Address Resolution Protocol is? It is responsible for the finding the physical address using the IP address. Means finding the physical address is nothing but the MAC address. Finding the MAC address using the IP address. That is the Address Resolution Protocol. These are the different protocols we are using in Internet layer. And next layer is the Network Access Layer. This is the fourth layer in the TCP IP reference model. It is the lowest layer of the TCP IP model. And the combination of the physical layer and data link layer is nothing but the network access layer. The main responsible here is transmitting the data in between the two devices, means node to node delivery from one node to another node. How the data is going to be transferred. That is the main responsible of the network access layer, and it converts the information in the form of signals. Already we discussed whatever data is going to be there, means final layer is physical layer is nothing but the here is network access layer only, right? This is network access layer. Whatever data is there, that is in the form of bits, that may be zeros and ones only, right? This information is sending through this some physical medium. Through this physical medium we are sending the data. Yes, right? This physical medium. If it is the wired medium, it is going to be transferred in the form of signals. If it is the wireless medium, it is going to be transferred in the form of waves. That is also divided. If it is Ethernet cable, if it is the Ethernet cable in wired medium, the data is going to be, whatever data is going to be transferred, that is in the form of electrical signals. And if it is a fiber optic cable, the data is going to be transferred in which signals? So if it is wired, it is signals. If it is wireless, it is in the form of waves. At the same time, fiber optic cable means it is in light waves, light signals, electronic and light signals. And if it is wireless, it is a radio waves, satellite waves, all comes under wireless communication. That is in the form of signals. And next, it uses the physical address. Physical address is nothing but the MAC address for each and every system for mapping the path of the transmission. Means exactly which device I want to reach the data, exactly which device I have to receive the data. That is the physical address using media access controller address. It is the unique address for each and every device. And the signals are directly interfaces with the network medium, like coaxial cable. These are the different cables we are using in network access layer. Coaxial cable, fiber optic cable, twisted pair cable. These are all comes under which medium? These are all the wired medium. So this is about the network access layer in TCP IP reference model. These are the 4 layers in TCP IP reference model. Now let us see the protocol data unit of the TCP IP. What is this protocol data unit? It is the named according to the protocols. What are the protocols of the TCP IP? Based on that, it is called as protocol data unit. Means each and every layer, what is the protocol data unit? Means if it is take it as the application layer, it called as a data. And if it is a transport layer, it called as a segments. If it is a network layer, it called as a packets. If it is the data link layer and physical layer, it called as the frames and bits. This is nothing but protocol data unit. Coming to this diagram, consider here is the user. I am the user. I am sending the data. How the data is going to be transferred here? First, I am selecting the application is email application. Through email application, I am going to send some document file. So, this is in the form of data only in application layer. Whatever data name is, here is data only. So, this is nothing but data. That is application layer. I am coming to next layer is the transport layer. It is added to the transport header. At the same time, data is also there. It is in the form of segments. The transport layer protocol data unit is the segment. And coming to the next layer is the network layer. It is transferred to the network header. That is, network header is added. Transport header is there. Data is also there. So, here extra is network header is added. It is in the form of whatever protocol data unit, that is in the form of packets. And coming to the network access layer, whatever data is coming from the network layer, that is, here is network header is there, transport header is there, data is there. This already there. Extra it is added as frame headers. Frame header is nothing, frame header and trailer. These two are added to the data link layer and physical layer. That is the combination of both. That is network access layer. Network access layer is the combination of these both, right? Frames and bits. Like this, the data is going to be transferred from layer to layer in TCP/IP reference model. This is the protocol unit diagram for TCP/IP. And next one is the differences between TCP/IP and OSI reference model. What is the main differences? The full form of TCP and IP already I told. Transmission control protocol and internet protocol. It is a practical implementation. And coming to OSI is a open system interconnection. This is the full form and it follows the theoretical approach. TCP/IP follows the practical and OSI follows the theoretical approach. At the same time, in 1982, this TCP/IP model became as standard language, that is ARPANET, Advanced Research Projects Agency Network. That is the full form of ARPANET, that is Advanced. ARPANET is nothing but the Advanced Research Project Agency Network. That is the full form of ARPANET. And coming to OSI, in 1984, this model was introduced by ISO, that is International Standard Organization. And next one is, it is having the 4 layers. TCP/IP is having 4 layers and coming to it is having the 7 layers. These 4 layers are network interface, internet layer, transport layer, application layer. These are the layers in TCP/IP. And coming to OSI, it is having the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are 7 layers in OSI reference model. Here it is 4, here it is 7. These are the layers in OSI and TCP. And coming to TCP/IP, it is a horizontal approach. And coming to OSI, it is a vertical approach. And it is in TCP/IP, it is a protocol dependent. At the same time, coming to OSI, it is a protocol independent. And coming to TCP/IP, it is more reliable than OSI model and it is less reliable than the TCP/IP model. These are the differences between OSI and TCP/IP reference model. Let us see this diagram was the relation between these two reference models. Those are TCP/IP and OSI reference models. In OSI is having total 7 layers, right? Transport, network, data link, physical. These are all the 7 layers in OSI reference model. And TCP/IP is having the 4 layers. Here is 7, here is 4. So, combination of these 3, application layer only in TCP/IP, transport is transport only, network is network only, data link and these two combination is called as a network interface in TCP/IP. The main functionality of both reference models are the application service in application layer. Presentation is talking about the format and it is talking about the establishing the connection in between the host. This all comes under in transport layer. And next one is the transport layer is transport protocol and error handling. These two comes under transport layer. And next one is the network layer. Network layer is talking about the logical addressing, means using the IP address we are transferring the packet from host to destination. That is the main functionality of the network layer. Coming to the network interface in TCP/IP, that is data link layer, is physical addressing, talking about the MAC address, means one hop to another hop, one node to another node, how the data is going to be sent. At the same time, network interface, that is physical layer, is sending the data on the physical wise. So, coming to the data names in application layer, here all these layers called as a data only. In transport layer, the data name is segments. In network layer, the data name is packets. In data link layer, the data name is frames. And physical layer, the data name is bits. These are the data names for OS and TCP/IP reference model. Example for application is SMTP, FTP, Telnet, all comes under the examples for application layer. And coming to the presentation layer, examples are format JPG, format GIF, HTTPS, all comes under presentation format. And coming to session layer is NetBIOS, peer-to-peer transfer protocol, all comes under the examples for the session layer protocol. And transport layer examples are the TCP and UDP, already we discussed today's class. And next one is the network layer examples are the IP, you can take it as a IP, ICMP, you can call it as a ICMP, all comes under the examples for this. And router, gateways, all examples for the network layer. And coming to the data link layer, the examples are bridges, switches, all the examples for the data link layer. And physical layer is repeater, hubs, modems, cables, all are the examples for the physical layer. This is about the relationship between the OSA as well as the TCP/IP reference model. And let us see the summary of today's session. First, we discussed what is TCP/IP reference model, and next we have seen what is TCP/IP architecture, and next we discussed what are the different layers in TCP/IP architecture. Those are the application layer, transport layer, network layer, and network access layer. These 4 layers we discussed. At the same time, we discussed what are the different protocols are there each and every layer. Those also we discussed in today's class. And next we discussed TCP/IP protocol data unit. And finally, we discussed the differences between TCP/IP and OSI reference model in computer networks. Those all we discussed in today's session. Thank you.